In this video, I will focus on answering questions related to the topic of Group 7 elements. So if you are struggling with this topic, please watch this video till the end because I'm going to answer two different questions from two different exams to cover all the points that are most likely to be in your exam if you have a question about Group 7 elements this year. So this is the first question. This is from 2024 exam paper 1, and this is about chlorine. So the main focus of the question is about chlorine. The first question, to give an equation to show how chlorine forms an acid solution in water. Remember that when chlorine reacts with water, it can either give hydrogen chloride and oxygen, or the chlorate one and hydrogen chloride. If they only ask you about acidic solution, you can put any of these reactions or any of these equations. But if they specifically tell you that it forms two acids, then you have to put the chlorate one and the hydrogen chloride. So now I'm going to put just the one that is chlorine plus water. That gives you hydrogen chloride and oxygen, and then I need to balance this one. So now there are two of the water, and that means I'm going to have 4 hydrogen chloride and 2 of the chlorine. Give an equation for the reaction between chlorine and cold dilute aqueous sodium hydroxide. This is a disproportionation reaction where chlorine will be oxidized and reduced to give sodium chlorate 1 and will give also sodium chloride and water. So now chlorine plus sodium hydroxide, that gives us sodium chloride and sodium chlorate 1 and water. Again, let's balance this one. So we need 2 of the sodium hydroxide. That should cover everything. In acidic solution, chlorate ion oxidizes chloride ion to form chlorine. And now they ask you to deduce the half equation for the oxidation of chloride to chlorine and the half equation for the reduction of chlorate to chlorine and the overall equation for this reaction. The oxidation of chloride to chlorine should be very straightforward because it's just 2 of the chloride will give us the chlorine plus 2 electrons. And then the chlorate one. So how would we write this? We don't need to memorize these at all because you can balance it simply. So the chlorate will give us the chlorine. And now let's balance. First, let's balance the chlorine or the chloride. So we're gonna have 2 of these. Now let's balance the oxygen. We have in total 6 of the oxygen. So we're gonna balance it by adding 6 of the water molecules here. Now we need to balance the hydrogen. We have 12 hydrogens, so there are 12 hydrogens. And finally, let's balance the electrons. So we would need 10 electrons here. Now, in the first equation, there are 2 electrons. In the second one, there are 10 electrons. To add these two, we need to balance the number of electrons on both equations. So the first equation, the oxidation one, we will have to multiply everything by 5. So that will give us 10 of the chloride, will give us 5 of the chlorine, chlorine, and 10 electrons. Now add these two together, the electrons will cancel each other out, and then we add everything. So 10 of the chloride plus 2 of the chlorate plus 12 of the hydrogen ion. That will give us, here we have 5 chlorine and here we have 1. So in total there are 6 of the chlorine and 6 of the water. You can divide everything by 2 as well, and that gives you 5 chloride to 1 of the chlorate and 6 hydrogen ion to give 3 chlorine and 3 water. Any of these will be accepted. The next question is about the reaction between solid sodium chloride and concentrated sulfuric acid. Remember the reducing power of the halides. The reducing power of the halide increases as you go down the group. The chloride is not a good reducing agent. It will not reduce the sulfuric acid. It will just displace the hydrogen on the sulfuric acid. So the equation here is going to be sodium chloride plus the sulfuric acid. That will give you sodium hydrogen sulfate and hydrogen chloride. So what is the role of the chloride? The chloride hasn't been oxidized or reduced, so it's not a reducing agent or oxidizing agent. It's simply a base or a proton acceptor. So it acts as a base in this reaction. All right, so the remaining questions are about shapes of molecules, so I'm not going to cover that now because I'm focused on group 7. And now we have another exam question about group 7. The type of question is a bit different, but there are some similarity, however. The first question again is about chlorine, where chlorine is added to some drinking water to water supplies to decrease the risk of people suffering from disease such as cholera. State why the amount of chlorine added must be controlled. We know that chlorine is poisonous or is toxic, so we have to control the amount of chlorine. So you simply can say chlorine is toxic, and that should get you the mark. Give an equation for the reaction of chlorine with water to form solution containing two acids. So this is the same question we just answered. However, they now asking you specifically about the one that will give you the two acids. So we have to write the disproportionation one, which has a form of, which forms the chlorate one and the hydrochloric acid. So the equation here is that chlorine reacts with water, and this is a reversible reaction, by the way. So that will give you the acid of the chlorate one and the hydrogen chloride. So these are the two acids formed here. So this is the equation you want. Don't write the other equation, which gives you hydrogen chloride and water and oxygen, sorry. Then they ask you to explain with reference to electrons why this is a redox reaction. So this is a disproportionation reaction. Chlorine has been oxidized and reduced. So first, chlorine is oxidized by losing electrons to give the chloride plus in chlorate. And chlorine is reduced by gaining electrons to give the chloride. So this is how to answer this particular question. A student bubbles chlorine gas through a solution of sodium iodide. So now we are talking about the oxidizing power of the halogens. And we know that as we go down the group, the oxidizing power of the halogens decreases. So chlorine can displace iodide and bromide from their salts, but the iodine and bromine cannot displace the chlorine or cannot displace chloride. So now we are reacting chlorine with sodium iodide, which means that there will be a displacement reaction here and there will be a redox reaction. So state the observation. So the observation, sodium iodide itself is a colorless solution. And when you add chlorine to it, then iodine will be formed and iodine will turn the solution into brown solution. So solution turns brown. So this is the observation. This is due to the formation of the iodine. Give an ionic equation for this reaction. So this is chlorine reacts with the iodide. This is just the ionic equation that will give us two of the chloride and the iodine. The student adds few drops of concentrated sulfuric acid to a small amount of solid sodium iodide. Remember, this question is about the reducing power of the halides. Iodide is the most reducing, or it has the highest power. It will usually reduce the sulfuric acid to give two different gases containing sulfur, which are the hydrogen sulfide and the sulfur dioxide. Remember that bromide has less reducing power, so it will only give you sulfur dioxide. It will not carry on to reduce it to hydrogen sulfide. And then fluoride and chloride are not reducing agents. They just act as base or proton acceptor. So they are not going to reduce the sulfuric acid here. So the two gases, sulfur-containing products, are formed. Give an equation for the formation of each of these sulfur-containing products and state the role of sulfuric acid in the formation of these products. First of all, the role of the sulfuric acid. So we know that the iodide is going to be a reducing agent and it's going to reduce sulfuric acid, which means that sulfuric acid is an oxidizing agent. So first of all, let's answer this one. So sulfuric acid is oxidizing agent. So now let's write the two equations. So you don't need to memorize this equation. You just need to know what are the products. We're gonna construct these equations from the two half equations. So the first one is the iodide is going to be oxidized to give iodine, and sulfuric acid is going, or the sulfate is going to be reduced to give sulfur dioxide. So this is the first one, and then we're gonna add the two equations together. So first of all, first one is the iodide. So two of the iodide will be oxidized to give iodine and two electrons, while the sulfate itself is going to be reduced to give sulfur dioxide. Now we need to balance this one. There are four oxygen on the left-hand side, two oxygen on the right-hand side. Need to balance this with water. So we need two extra oxygen. So two H2O. Now let's balance the hydrogen. There are four hydrogens on the right-hand side. So let's add four protons. And then finally, let's balance the signs or the charge with electrons. So we need to add two electrons to have zero a charge on the left-hand side like the right-hand side. Now, both of these equations have two electrons, so let's add them together. So 2 of the iodide plus the sulfate plus 4 of the protons will give us the iodine plus sulfur dioxide plus 2 water molecules. Now we have everything balanced and we have this equation. The second equation is for the sulfate to be reduced to give hydrogen sulfide. So now we know the equation for the iodide. We don't need to repeat it now. So now let's focus on the reduction. So the sulfate will give us hydrogen sulfide. So now let's balance this. So there are four oxygens on the left-hand side. So need to balance this with four molecules of water. Now let's balance the hydrogen. So we have 10 hydrogen on the right-hand side. So need to add 10 of the hydrogens. And then finally need to balance this with the electrons. So we need 8 electrons on that side. So we have zero charge. Now let's add the two equations together. The first equation has only two electrons, so we need to balance this one by multiplying everything by 4 to have 8 electrons, which means we're gonna be 8 iodide will give us 4 of the iodine and 8 electrons. The electrons will cancel each other out, and then we just add the two equations. So 8 of the iodide plus sulfate plus 10 hydrogens that give us hydrogen sulfide plus 4 iodine plus 4 of the water. And this is the balanced equation. We don't need to memorize it. We just can work it out from the half equations. The final question is about the identity of unknown sodium halide. So there is an unknown impure sodium halide, and they add acidified silver nitrate solution to this solution. Remember, in this experiment, silver nitrate can differentiate between the different halides because fluoride will not give anything. So we're going to have a colorless solution with fluoride. The chloride will give white precipitate with silver nitrate, acidified silver nitrate. The bromide will give cream precipitate, and then iodide will give the yellow precipitate. But we can even differentiate between these by using the ammonia. So if you add dilute ammonia after you form the precipitate of the silver halide, then the silver chloride will dissolve in dilute ammonia. Silver bromide will dissolve only in concentrated ammonia, while silver iodide will not dissolve at all. So this is an extra step if you want to differentiate between the different halides. And fluoride, we don't need to use ammonia because it doesn't make any precipitate anyway. So what are the observations? The first observation is the bubbles. So the bubbles of the that has formed is due to the presence of the carbonate, because we used acidified silver nitrate. Normally we use acidified silver nitrate to exclude the carbonate, so it wouldn't make a precipitate with the silver. The silver carbonate will be a precipitate as well, or insoluble. So we need to exclude the carbonate completely by adding the acid or using acidified. So if there are any bubbles, that means that you have carbonate. And then they say there is a colorless solution. So these are the two observations. meaning the colored solution means the halide here is the fluoride. So first of all, identify the sodium halide. So this is going to be sodium fluoride because we didn't have any precipitate form. Identify the gas. This gas is carbon dioxide that comes from the presence of the carbonate. Then they want you to give an ionic equation for the formation of this gas from the impurity. So the ionic formation, the ionic equation going to be the carbonate plus the acid, two of the protons or two hydrogen plus, that will give us carbon dioxide and water. So this is the ionic equation.